cloudscale, jobs@comcast.com, and we're happy to hear from you. Thank you.
Okay. So if I didn't say earlier, Jan is actually going to be our moderator and tonight, and hopefully you guys know that we're doing a panel discussion with all the visualization solutions here tonight. So I just wanted to introduce just their names, and I am going to have pull their names to have them speak a real quick, 5 minutes each. They get a solo opportunity before we start the panel. So we're very excited to have Farzad Aref. He's the VP of Product Management at Zoom Data. And then we have Paul Lifford. He's the Global Director of Technology Partners at Tableau. We have Ben Lard. He's a data scientist at Cap One Labs, and he's representing our open source D3 solution. And we have Keith McClellan. He's the longest title ever. Director of Solutions Engineering and Technical Director of Federal Programs at Platfora. So, okay, Jan, you want to pull a name and see who goes first?
Keith. All right.
Okay.
So, I don't have any slides. So I don't have any slides because I figured with the title as long as that, I need to save some time for the rest of this week. So Platfora provides an end-to-end solution for your data scientists, your data administrators, and your business analysts to work in the same collaborative environment to discover actionable insights out of your big data holdings. We're based entirely on top of Hadoop, so it's all Hadoop and MapReduce and Spark. And we provide a visual interactive interface for doing exploratory analytics on that data. And I will give the rest of my 5 minutes back to the rest of the panel so we can have plenty of time to do the panel discussion.
Thank you.
Thank you.
How's that?
Hi everybody. I do have slides, but I figured as a visualization company, hopefully my slides will be more visual and also help me kind of tell the story of Zoom Data. So I had a product for Zoom Data. At Zoom Data, we want to change the way people see and interact with data. If I can try it.
You want this one?
There. Perfect. So as we look at data, right? So our philosophy right now is if we look at data, it sits in a lot of different places. It could be in relational databases, it could be in search stores, it could be in Hadoop, NoSQL, etc. As we look at the visualization side, in the world of JavaScript and web-based visualizations, there's a lot of flexibilities of how you can tell stories and visualize the data, so we want to embrace that. And then from a device perspective, it's a connected world, right? Whether you're on your phone, your tablets, or computers, you still want to be able to have access to this information. So what we wanted to do 2 years ago is kind of rethink the way of a visualization tool of how it should be living in today's world. So that means take advantage of modern architecture, focus on the business user, so no programming, and then make sure that you're performing. Quickly, from a traction perspective, the company was founded 2 years ago. We have about 20 engagements that we closed in our first year. One customer alone represented 10 million, just so you guys get a feel for deal size. And we are venture backed. We just raised our B round funding led by Excel Partners. And then from an architecture perspective, so our philosophy is data is coming from a lot of different places. And what we want to do at Zoom Data is be able to connect to that data, allow people to visualize that data, and also interact with it. From a Spark perspective, we're one of the early users and adopters of Spark, and we use that in a variety of places, whether it's used to connect to data, whether it's ingrained in our architecture, or a place that we want to land data in. So I'll try to talk about that through my demo. So I'll do a quick demo, and I'll really focus on big data. So in my demo, it's 1 billion records. What I want to show is a pivot table, the coolest pivot table you've seen on the web. You're going to have the ability to instantly look at 1 billion records as you're interacting with the data, right? And this will cover high cardinality scrolling. It's going to cover simultaneous caching in Spark, and also the ability to look at multiple visualizations at the same time. From an architecture perspective, to show you kind of visually what's happening, so I am the user, right? Working with Zoom data as I'm kind of requesting information by interacting with the data. What we do actually on the server side is break that request into a bunch of tiny requests. In this example, I'm actually going after 1 billion records sitting in Cloudera and Impala. So what we're doing is, as we kind of break up the requests, a bunch of little requests, we're getting the results of that back through what we call micro-querying, right? And then data sharpening. And the way we call data sharpening, the way we describe it is, if you think about streaming HD content, rather than waiting for it to buffer, you kind of see the visualization a little bit fuzzy, and then it gets sharpened. So we kind of use that same concept for visualization, so you don't have to wait, you get to see the results instantly. And then as you re-ask the questions, whether you're another user or you want to kind of change the order, etc., that's also getting simultaneously cached in Spark, so you don't have to make a trip back into the database. What I did was I just made a quick video of it, just so I didn't want to deal with some changing of the computer, but I did this last night. So this is the Zoom data interface here. What we're showing is the variety of connectors that we have. In this case, I have data sitting in Impala. This is the pivot table in the web base. What you're going to see right away on the top is the data coming in with percentages showing you the progress of the results coming. And as that's occurring, you could see me just interact with it. So I don't have to wait. I can change sort orders. I can change column orders. And then while that's sharpening, I can go ahead and start building a dashboard. So in this case, I'm going to go ahead and bring in a bar chart, looking at the same data, just looking at it from a bar perspective. And then from there, as the results are coming, I can go ahead and drill into Los Angeles. I can break that out, the sales in this case, into different income brackets. As I look at the various income brackets, again, as the results are coming in, I don't have to wait. I can go ahead and grab one of those elements and go ahead and trend it. So when I trend it, you could see the dots coming in as the results are coming back. In this case, I'm looking at sales for that specific income bracket. And then from there, I can go ahead and drill in. So in this case, I'm looking at hours. So I'm going to go ahead and break it down into minutes. And again, see that information coming in. And then, in this case, it's volume, so I'm going to actually change that and look at sales. And let's say we have both actual and planned sales. So I can go ahead and bring all of that stuff together. So this is Zoom data. We're hiring, so if anyone's interested, please feel free to check our website or talk to me after the discussions in the panel. Thank you.
Thank you very much. You're up next. Okay, there you go. Need the video ready?
Yep. Hi everyone, my name is Ben Laird. I'm a data scientist at Capital One Labs. That's on my comments. We're just going to jump right into a demo here. I don't really have a specific product that we build in the labs. Pretty much everything we do is open source. Data science at Capital One is already a pretty new phenomenon. It's been kind of acquired. Capital One acquired a small tech company in New York City a couple years ago called Bundle, and it's grown from a couple data scientists now to we're up in the dozens. So we're still pretty small compared to the rest of the company. Our largest data set and our richest data set by far is credit card transactions, obviously, which has this geographic visual component that almost every transaction has a latitude and longitude to it. It has a location that's intrinsic to a transaction. And so most of my work is Hadoop machine learning kind of on the back end. It's working through the shell. It's not very visual or pretty or really anything. But there's certain applications where the visual aspect of that data is really important, where there's certain insights you might gain looking at the data that you might not get as quickly by running a machine learning model or something to that effect. So I'm going to kick this off here while I'm talking. This originally was going to be my timer to keep me at 5 minutes, but I started talking about it.
Do you want to make it bigger?
Yep. There's code here. We're not going to actually talk about the code, so don't worry too much. So this is kind of an example stack, an app that I built specifically for this use case to present tonight. The idea of what would you have to build to visualize a live stream of credit card transactions. And there's a bunch of different use cases. This particular one was very simple. It was just seeing average transaction price in a geographic area. In this case, New York City by zip code. But the math being done in this case is incredibly simple, but there's a lot of use cases. If a call center agent wanted to see a live, some type of stream of transactions from a particular account holder, something huge, not just Capital One, but in the whole credit card space, is visualizing transactions from fraud. There's definitely a geographic aspect to that. If you see certain clusters, that might mean that a merchant was compromised. Someone's running a skimmer at Home Depot, or there have been certain cases in the news where that's happened. So my particular example here is using Apache Kafka for a live stream of transactions. This is all done just on a laptop in a Docker container. We can talk, I guess, a little later if people have certain questions on the performance of this, but I'm generating about 50 transactions a second on the back end. And this stream from Kafka, this topic's being read by Spark Streaming, which is actually doing my processing in this case. And like I said before, it's aggregating by zip code and just doing a running average of the transaction price. But obviously, for those of you, Spark could be much more advanced with maybe a machine learning model that is predicting fraudulent transactions or whatever you might be doing for the particular use case. From Spark Streaming, it's writing these aggregations every 2 seconds out to a Mongo database into a CAP collection, so you can very quickly grab the latest records that have been inserted into this. You can basically, you have a tailable cursor, kind of like a circular buffer, and you can just grab the latest records. And then I have a Mongo server also running in this my container, my Docker container, that's listening for new records that are being inserted. Didn't sync up the timing totally, but this will eventually make it back to the animation. I have the code, so Node is listening, and I have Socket.io running on the back end, listening as new records are being inserted into my MongoDB database. Those records are being pushed over Socket.io onto my front end to my D3JS visualization. And it's polling every couple seconds. It's giving you this live view. If anyone's played with D3 before, we have some pretty nifty ways to play with maps. And it's obviously building this from the ground up. And this is something to talk about. It takes much longer. That's why it looks kind of ugly. But really, the point of this exercise was building the architecture around it and showing kind of the data flows and what you can do. So you're updating this live map every couple seconds, and then creating some time series. So if this were built out more, you have a drop down so you can look at these records by zip code or whatever you wanted to do, and then you can see this being animated. This will eventually go back to the final view, and then I'll let that play just for a couple seconds. Spare you the minutes of just staring at code. It's obvious that I'm not a designer. In our lab, we would probably have a digital designer making this look even nicer. But this is the architecture behind what's going on here. And I think that was the interesting thing and fun kind of building this out.
Okay, so hey guys, this is Paul from Tableau. I'm going to keep the slides to a minimum. We have about 5 minutes, but I want to do a live demo for you, most importantly. So I'll just jump into it. At Tableau, we've had the same mission for 11 years, and it's simply to help people see and understand their data. And as basic as that sounds, it's really hard to make the easy look, to make it look as easy as I think we do, right? We connect to 42 different databases. We've been doing this a long time, and trying to make the product always easier and easier and simpler so anyone can use it. So when we say people, we mean everyone, right? From data scientists like Ben, all the way down to the desktop analyst who doesn't know how to spell SQL. It's kind of the way we think about it. So when you get into Tableau and Spark, it's pretty simple, and I'll just keep it to 4 basic points. Our Spark SQL connector is currently in beta. It's due out at the end of February, early March. We have hundreds of customers testing it already. One of the main points is there's no need to write complex SQL. We can always hop out and use APIs and do things, but really that's not our core. It's live connectivity to RDDS, Hive, Parquet, and JSON. And then we also have the ability, because of our other connections, to connect over other 40+ different data sources and engines. And I'll show you that today. So with that, I'm just going to jump into a demo. And I'm going to try to do this one-handed, so bear with me. So I've just opened our desktop, but at this point I haven't connected to anything. So in this case, I'll just look at more servers, and these are all the connections we've got. This is actually the beta of our product for version 9, which is coming out. And you'll note that we've got the Spark SQL beta here that I'm going to connect to. And then if I cut and paste works, awesome. I'm just going to flip my port, and I'm just going to one of the servers in our firewall, and I'm going to say OK. Okay, and so now I can simply go and navigate structures. I'm just going to click on the magnifying glass here and pick a default view. And then the data set I'm going to pick is not that large. It's probably 5-10 million. I'll give you the exact count here in a minute. But basically it's popular birth names for the last 100 years is the data subject. And now I've connected to it. I could join other tables and other connections here if I chose to. But in this case, I'm just going to hop into our designer. We've got our Show Me button here, which are our best-in-class visuals. So if you want to know how to bring any to life, you just hover over it, we tell you. Or you can just simply do things like double-click, right? And so I'm going to drop count in here. And what we're going to see pretty quickly here is that we've got about 296 million birth names across that 100-year period. It's not a distinct. I can do things like say, make this distinct if I choose to, right? And then I'll see that there's only, under 5,000 unique names over the last 100 years or so. If I ever don't like anything in Tableau, I can just go back. Infinite undo, I love it, my favorite feature. But if I do years, we'll automatically make some intelligent choices about what that visual should be. So now I can look at names by year. I could also do things like drop gender on the color palette and go see what gender looks like. So now I get a split between male and females over the last 100 years. In this case, I'm just going to take these back, and I'm going to show you a different way to look at it. Maybe we'll drop state here, and we're going to turn state into a map. And so we have out-of-the-box geointelligence. I'm going to create one filter just so you can see it a little bit better. I'm going to take Alaska and Hawaii out. Not that I don't love Alaska and Hawaii, but we're just going to pull them out so we get just the continental U.S. And I'm going to apply it. And I forgot to do one really important thing when I started the demo, guys, which was turn on the performance recording so I can show you what we queried at the end. But we'll take it from here. So now I've got this, and if I wanted to bring in another data source, so say I wanted to see populations by state, I can very simply just connect to a new source. In this case, I'm going to pick Excel. And I happen to have a Excel format here that's got populations by state. I'll drop that into the grid. I'll go back, and you'll note that I've got two connections now. And I could do things like just say, well, let's size categorize population by state. If I want to change the size of something so it's easier to see, it's simple enough. The color of this is a little hard to pick. There's a gradient kind of color here. So I'm just going to go here and say, give me a diverging color. And now we'll see a different application of that. I can do things like animate it if I choose to. So if I take a year and put it in a page header, now I can actually go through and say, oh, and wait a second. And then I can go in and say, go ahead and show me the change in population over years. And I'm slowly just playing out those years as I go. So this was a really quick example, all ad hoc, generated it. If I stop my query logger right now, it's going to give you a little bit less than what I had, but it's automatically going to generate a view so you can see the queries and things that we did as it related to the Spark source or any source we connected to. The last thing I'll finish with is I have an end result. So that was the 5-minute demo. Here's one that's more of a finished one with story points. And this took about 15 minutes to make, so it wasn't a lot longer than what you saw. But now we can actually go through and we can look at the narrative of birth names since World War II. So World War II happened, they invented the pill, birth rates happened to drop shortly after that, and then it gets pretty interesting as you keep going, right? So you can look at the different names over time, you can look at the populations by state, etc. So this is a more completed dashboard with story points which help you just narrate the business objective. That's the demo for me. I have one other slide to stick up for you, and that's really, and we'll leave these behind for you. You guys want to get in touch with anyone? Tableau's always hiring, as these guys are. tends to be the space we're in. But if you'd like to find out more, we have a link to a more detailed version of that video. You can always download our software for free and contact me or Jeff from our product team. Thanks, guys.
Gonna let you guys set up.
Okay, sounds good.
And I should